We're on topic 9, and we're on page 43, and what we're going to do is solve each of the following three systems: 1N, 1O, and 1R. So let's start with 1N, and here we're asked to solve the following system, which means that we have two linear equations here, and we're looking for the point of intersection. So whenever it says solve the following system, it means, okay, where do these two lines intersect? And what we're going to do is we're going to do this problem and the other problems by elimination. It's usually easier, the more complicated the coefficients are, to use elimination over substitution. So what we're going to do is we're going to do elimination. And here, if I look at the numbers, it's easier, I think, for me to eliminate the 2 and the 4 than it is to eliminate, or rather the x term, rather than it is to the y term, because the coefficients are a little more complicated. Here, I really only have to multiply equation 1 by minus 2, let's say, and I'll get minus 4x, and then when I add that to the 4x, I'm going to get 0. So the coefficients with the term that I'm trying to eliminate should be opposite. So I want to get minus 4x, and I have 5x on equation 2. I'm not going to change equation 2. I'm just going to change equation 1 to make it minus 4x, and in order to do that, I'm going to multiply 1 by minus 2 and then add it to equation 2. By the way, it's a good idea to just, put numbers here so you know what you're talking about. You can always refer back to these equations. So I'm going to multiply each term by minus 2. This will give me minus 4x here. Minus 2 times minus 8y gives me plus 16y. And minus 2 times 0 still gives me 0. So here's equation 1 after it's been multiplied by minus 2, multiplied each term. Equation 2 I'm going to leave as it is, and here the object is always to get these to be the same magnitude but opposite signs, so that when I add them, they add to 0. So minus 4 and plus 4 becomes 0. I add the 16y to the 5y, and I get 21y equals 0. So if 21y equals 0, I divide this by 21, I get y. I divide 0 by 21, I still get 0. So the y value of the point of intersection is equal to 0. Now I'm going to substitute y equal to 0 back into equation 1. Now I always substitute back into the original equation. So I'm going to substitute back into here. Okay, I'm going to substitute y equal to 0 into that equation. So I get my 2x minus 8y, but I'm replacing the y with the 0 equals 0. So all I've done in this is to replace with the y equal to 0 in equation 1. Of course, this is 0, and so 2x equals 0, so x equals 0. So the solution or point of intersection is 0, 0, because the x value is 0 and the y value is 0. Now, I'm now going to check the answer using equation 2. Since I used 1 up here, it's good to use the other equation here to find the solution. So the left side of this equation is 4x plus 5y. We go back into the original equation right here. It's 4x plus 5y equals 0. So the left side is 4x plus 5y. We replace the x with the 0 and the y with the 0. We sum these terms. This is 0 and that's 0, and we get a total of 0. And the right side of the equation was 0. 4x plus 5y equals 0. So we've shown that using this point fits this equation so that the answer is correct. So if we solve for the second variable using equation 1, we then use 2 to do the check. So over here, what we did is we substituted y into equation 1. We could have used equation 2. It would be okay. But then if we use this for the substitution, we should use equation 1 to check. So always use the alternate equation for the substitution and the checking. If you use 2 to do the substitution, then use 1 to do the check. Okay, the next problem is 1.0, and here we have 3x minus 6y equals minus 1, 6x minus 4y equals 2. The object is to solve, which means that these are two lines, and the question is, where do they intersect? Again, we're going to do this by elimination. We're going to eliminate one of the terms. It doesn't matter which term we eliminate. So it doesn't have to be the x, it can be the y. But again, here I only have to change the 3 into the 6 and make it the opposite sign. And so that's easier than working with the y terms. So I'm going to multiply each term in equation 1 by minus 2. Minus 2 times 3x gives me minus 6x. Minus 2 times 6y gives me plus 6y. And minus 2 times minus 1 gives me plus 2. So I multiply through this term by minus 2. Now, why did I do that? Because now these two have the same magnitude but opposite signs. So when I add them, I get 0. I'm going to put it in. 12y minus 4y equals 8y. 2 plus 2 equals 4. If I divide this by 8, I get y. If I divide 4 by 8, I get 4/8, which reduces to a half. Now what I do is I substitute y equals a half into this equation. So I'm going to solve for x, and because I know y, I've solved what y is. So I now have 3x minus 6 times a half equals minus 1. So substitute y into 1, and I get 3x minus 6 times a half. 6 times a half, the 2 goes into the 6 3 times, so it becomes minus 3 here with the sign minus 3, and the minus 1 stays the same. I transpose the minus 3 from the left to the right, and I get 3 minus 1, which gives me 2. I divide this by 3, I get x, and I divide the 2 by the 3, and I get 2/3. So I now know that the point of intersection is 2/3 because it's an xy pair. The x value goes first, and the y is equal to a half. So this is the point of intersection. In other words, the 2/3, 1/2 lies on this line, and it lies on that line. And the only way that one point could lie on two lines is if they intersect. So we check the answer by substituting x equals 2/3 and y equals a half into equation 2. So let's look at equation 2. It's 6x minus 4y equals 2. So I work on the left side, which is 6x minus 4y. 6 times 2/3 because x is 2/3. So I'm substituting x is 2/3. For the y, I'm substituting a half. So 6 times 2/3, 3 goes into 6 2 times. 2 times 2 is 4. Or we could say 6 times 2 is 12 divided by 3 is 4. 2 goes into the 4 twice, and I've got minus 2. So the left side reduces to 2, and the right side reduces also is 2. So the left side equals the right side. If I didn't have the values here, these were not correct, the left side would not equal the right side. So the third problem is number 1R. Solve the following system. Again, we have two straight lines. We number the equations. Always good to do that. And we want to know the point of intersection of these two lines. So what we're doing here is we're going to multiply equation 1 by -3 and multiply 2 by +2. Now, why do we do that? Well, we're going to make this into one term into -6y and another term into +6y. So if I multiply this term by 3 and this one by 2, it's going to work. Now, I could multiply this one by 2 and this one by 5 or -5, and I come out with the same answer. So it doesn't matter which term you choose to eliminate. You can eliminate the x or you eliminate the y. The answers will still be the same. So here I'm going to make this 2y into -6y. And in order to do that, I multiply each term in equation 1 by -3. So I get -15x -6y -3. Multiply each term by -3. I get -15x -6y equals -3. Now, I need to make this into the same magnitude but opposite sign. I want to make the 3y into 6. So I'm going to multiply equation 2 by 2. And I get 4x, when this is multiplied by 2, plus 6y. And 2 times -15 is -30. So when I add this y, I line this up. When I add these up, they come out to be 0. -15x plus 4x is -11x. And -3 and -30 is -33. So if -11x equals -33, then 11x equals 33, and x is 3. So I now have the x value for the point of intersection. I substitute x equal to 3 into equation 1. So I'm going to substitute the x equal to 3 and then solve for y. So I substitute x equal to 3 into 1. 5 times 3 is 15 plus 2y. Here I've got my 2y. Equals 1. So the 2y stays here on the left. I'm going to transpose plus 15 from the left to the right. It becomes 1 minus 15, which is -7. So if 2y equals -14, divide this by 2, I get y. Divide this by 2, I get -7. So the ordered pair is an x and a y value. X is 3 and y is 7. Now I check the answer using equation 2, which says that 2x, and there's a mistake here, so this should be 2x plus 3y equals -15. I've corrected it right over here. And so what I'm going to do is substitute the x equal 3 and the y equals -7 into this equation. All right, I get 2 times x is 3 and 3y. Y is -7, so I get 6 minus 21, which is -15, and the right side of the equation is -15. So let me just change this over here, and I should have a plus sign here. I'm going to change that. There we are. So this equation should be that. So you can see that we substituted again. This is the original equation. We substituted x equals 3 right here and y equals -7 because that was the ordered pair. When you do that to the left side, it comes out to be minus 15. The right side of the equation was minus 15. If these values were not correct, then the left side would not equal the right side.